All right, hi everybody. So I'm just gonna quickly go back to how we convert from rectangular to polar form in complex numbers, because I realize some of you are making mistakes for the angles. So I just want to make sure that we clarify that right now, because yeah, we don't want to carry mistakes like that. So just quick reminder, here you have it on the right side of my screen. To find a radius in polar form, we would have the square root of a squared plus b squared, which is a Pythagorean theorem. Now I'm going to use something maybe a little bit different compared to what you've seen, but I hope it's going to make things a little bit clearer. So I'm going to use something called theta hat. That is not the angle that we're going to use in polar form. It's going to be the inverse tangent of the absolute value of b over a, meaning that we're not actually going to take the sign that a and b are. I'm going to show you what it means, but just keep that in mind. And then theta is going to be, so essentially your theta hat, it's going to give you an angle in the first quadrant every single time. But it doesn't mean that your angle is always in the first quadrant. You're going to have to go take this angle and look in what quadrant it is and then find the actual angle. That's kind of where we're heading. So let's go ahead and do this. So the first example I want to give you is -1 plus I. Super important example. So let's go ahead and see where this number lies in the plane, right? So that's the first thing. So if you remember, we have our imaginary axis here, and this is our real axis. So if my real part is -1, it means that it's here. And then my imaginary part is I, positive I. So it means that my complex number lies in the second quadrant right here. Okay, so this thing doesn't want me to draw it. Okay, it's somewhere here, okay? So essentially, what we're going to be doing here is, I told you we're going to find theta hat, yeah? So theta hat is this angle here. It's going to be the angle that we make with the x-axis all the time. This is not the angle we need. We are going to need this angle right here. This is the one that we want to look for. So this is theta. That's our guy, this one. So first step is we're going to find a radius. Second step, we're going to find theta hat. And then third step, we're going to find theta. So for theta, we're going to think a little bit, right? But you've been doing this in trig for an entire month and a half last year. So I hope that you're going to remember how to do that. All right, let's go ahead and do it. So first step is radius. So radius is going to be the square root of a squared plus b squared. So square root of 1 plus 1. This is a plus, which is just square root of 2. And that's that part. I think most of you got it. Now, theta hat is going to be the inverse tangent, okay, of the absolute value of b over a. So I'm going to write it all down. Usually I skip that step. So 1 over -1 is -1, but then if you take the absolute value of that, it's just 1, right? So this is the inverse tangent of 1, which if you want, you can get your calculator to calculate, but you don't have to. This should be 45 degrees or pi over 4, whichever one you prefer. I tend to like my radians better, but I think for this one, I'll do it in degrees. All right. So we found out 45 degrees, but again, look at your picture. Clearly, this number is not at a 45-degree angle, right? The angle that we just found is theta hat. It's this one here. I hope you can see it. This is the angle we found. So again, not the angle we're looking for. So the angle we are looking for, you're going to have to think. So if this part here is 45 degrees, and the angle going from one side of the x-axis to the other side is 180, then it means that the remaining angle should be 180 minus 45 degrees. That's my angle, which should be 135 degrees if I'm not mistaken. Okay, so this is the angle that we need, meaning that your number in polar form is the following. It's going to be the square root of 2, and then it's going to be cis or cosine plus I sine theta, whichever one you want, of 135 degrees. That's our answer. All All right, so if you got it, you don't have to keep watching this video. Just make sure, again, like I always draw my complex number. I always do it. Because otherwise it's so easy to make a mistake in the angle and not realize it. You just got to look at your angle, 135. Does that make sense? Yes, it does. It's in the second quadrant. We're all good. But if you don't draw it, you're not going to be able to analyze that. So yeah, just make sure that you go and you draw. Drawing is a good thing. All right, so if you got it, ciao. And then if you want more examples, just stay with me. Let's do that. I have more. We're going to do one for each quadrant, if I can move this, of course. Okay. All right, one more. So let's draw this again. So again, my little Argand plane. -1 is going to be here. Let's draw it a little farther off because I have a root 3 going on. -1 is here. And then minus square root 3 is going to be somewhere here. Okay, so my complex number is in the third quadrant. So where's my, when I find theta hat, I told you it's always the angle that you make with the x-axis, right? So theta hat is this guy. And then the one that we are actually looking for, theta, will be the one that you make with the positive x-axis. So it's going to be this angle here. So I'm just going to write it down so that we have it in mind. All right, let us find our radius. Radius is going to be the square root of -1 squared, which is just 1, plus root -3 squared, which is just 3. So square root of 4, we get a radius of 2. Isn't that lovely? All right, so we have that. Now let's find theta hat. So we said theta hat is just going to be the inverse tangent of the absolute value, so the positive of b over a. So b is root 3. Or the positive of b is root 3. And then the positive of a is 1. So we're looking for the inverse tangent of the square root of 3. So I'm just going to go ahead and use my calculator at this point. We have calculators. We might as well use them. The inverse tangent of the square root of 3. I get pi over 3. I'm going to do this one in radians. All right. So again, this is theta hat. It's not theta. Now we got to find theta. So just looking at our beautiful little picture here, if this here, if the value of this zone is pi over 3, then the value of the entire thing, so the theta in red, is, so this first half, right, of the plane is pi. So we should have pi plus pi over 3. So that's going to be our angle. Let me go back here. So pi plus pi over 3, which should be 4 pi over 3, I believe. All right. Now all the work is done. So your number in polar form should be 2 cis of 4 pi over 3. All right, let us go ahead and do one last problem. Again, let's graph it. Okay, so this one, as you follow the thread, it should be in our fourth quadrant. Wow, sorry, it's hard this morning. All right, so let's see. So we've got 3. 3 is here for the real part. And then let's pretend this is a 3. We are going to get our -4 somewhere here. So our number is going to be somewhere here. Theta hat, angle formed with the x-axis always. And then the one we are actually looking for is the one that is going counterclockwise. So we're looking for this angle. Let's go ahead and do our calculation. Radius is going to be the square root of 9 plus 16. So nice. 5. Theta hat the inverse tangent of the positive of 4/3, because b over a. Again, taking my calculator, going to calculate that. So 4/3. I'm going to do this one in radians, in degrees, because it's not super nice. So let me just change the mode of my calculator. I get 53 degrees. This is a 4, by the way. It's a really awful 4. My apologies. Okay. And then, so 53.13 degrees. This is what we have. Again, this is the angle theta hat. I need to know what theta is. So a complete circle would be 360 degrees. So I need to minus the angle theta hat to get my theta, right? So this is going to be, theta is going to be equal to 360 minus 53.13. $306.87. Makes sense, right? This is a pretty big angle. It's definitely in the fourth quadrant. So our beautiful little number is going to be 5 cis of 306.87. Okay, I hope this was helpful. Maybe just one last thing. If you're confused about how to find theta, it's actually pretty easy to know. So if you are in the first quadrant, it's just theta, you're not doing anything. If you are in the second quadrant, you're going to be doing 180 minus theta hat. Oh my goodness, this can't write. This one here, or I mean, depending if you're in radians or in degrees, this could also be pi. This one here would be 180 plus theta hat, or again, this could be pi if you're in radians. And finally, your last quadrant is going to be 360 minus theta hat, or 2 pi minus theta hat if you're in radians. So this one here, theta and theta hat are the same. So if that's something that's confusing, just follow this method and you're always going to get it right. All right, have a good day, guys. Bye.